Americans praised the Spitfire, the Mustang, the Zero, yet almost no one remembers the machine that quietly saved thousands of pilots, then vanished from history. The Curtiss P-40 Warhawk wasn't built to dominate the sky, it was built to survive inside it. Forged in steel, welded by hand, powered by human determination, it flew lower, slower, heavier, yet always came back home. Its name never shown in the headlines, but every dent along its skin carried proof of a single truth. In war, brilliance fades, durability endures. But that's only the surface of a forgotten file. The next chapter reveals why America once tried to conceal its birth, and why fewer than 0.01% of people have ever seen its original blueprints. Before the Warhawk took shape, the 1,930 seconds were an age of transition when aircraft evolved from wood and fabric to aluminum and steel. America had speed, but not endurance. Technology, but not philosophy. While Europe chased aerodynamic elegance and Japan perfected agility, engineers at Curtiss Wright in Buffalo asked a radical question. If we can't fly higher, can we fly longer? Among hammer strikes and radiostatic reporting the approach of war, they drew designs not for beauty, but for survival. From that question came a new belief. Simplicity could outlast sophistication if it never broke. Yet this was only the opening move of a sequence so bold, the Pentagon once considered erasing it from its records. In the next section, you'll see why they called it the machine born of Curtiss steel.
Rising global tensions in Europe.
Inside the Curtiss plant in 1938, fire and oil composed an industrial rhythm. The Warhawk's frame was shaped by hands, aluminum sheets bent by eye, rivets tightened by sound. Its skeleton steel tubes and coarse panels wasn't graceful, but it was honest. Engineers traded speed for strength, aesthetics for survival. It could dive at 400 miles per hour without tearing apart, take bullets, and still hold a straight line home. In war, beauty doesn't save lives, durability does. This was only a fragment of technical files locked away for 80 years. The next part uncovers the secret heart of this machine, its Allison engine once classified as restricted U.S. technology. 350, 510, vertical bar milestone, 03, the Allison heart. The Allison V-1710 wasn't a marvel of innovation. It was a masterpiece of practicality. 12 cylinders in a V formation, engineered for ease, trust, and repair. While others chased superchargers and altitude records, Allison chose reliability, fewer parts, fewer failures. Mechanics could strip it on a dirt runway and rebuild it by dusk. When pilots pushed throttle to the edge, pistons screamed at 3,000 revolutions per minute, yet held steady. It was the heart of a machine that refused surrender, living only to continue. Nia, if you think the engine was its only secret, you're mistaken. Next, we'll decode the strange shape that baffled competitors, an aerodynamic formula that even NASA would later borrow. The Warhawk's wings were drawn by mathematics, not inspiration. Built with NACA airfoils, they sacrificed agility for stability. A broad tail kept the aircraft balanced in steep dives. Its long nose shielded the engine from violent airflow. It didn't dance like a Zero, it fell like a hammer. Boom and zoom turned gravity into an ally, momentum into armor. Every second in the air became an experiment in airflow. drag, and lift a contest of physics and nerve. Yet even perfect equations mean nothing without human hands. Up next, the truth about field engineering. The improvised battlefield repairs the U.S. military kept classified for decades. Milestone 05. Under desert heat and jungle rain, the Warhawk survived through the people who maintained it. They patched bullet holes with tin, re-riveted with hammers, tuned engines by ear. Field engineering wasn't in any manual. It was intuition, exhaustion, and belief. Oil mixed with dust, wrenches rusted in salt air. Yet at sunrise, the plane flew again. Its simplicity was salvation. No fragile sensors, no electronics, only cables, levers, and will. In war, perfection breaks first. Reality endures. The reports about these mechanics were once stamped top secret. The next section reveals how their work quietly shaped every modern fighter from the P-51 to the jet age. When the war ended, the Warhawk vanished from the sky, but not from engineering memory. The Mustang's sleek efficiency carried its discipline. The jet era learned that complexity isn't always progress. Even today, when alloys are tested for stress and fatigue, echoes of Curtis steel still resonate. The Warhawk was no relic, it was a teacher. It proved that engineering isn't about chasing perfection, it's about understanding failure and designing around it. And that understanding leads to the final truth. The principle every engineer, every generation must remember. Respect the process. The P-40 Warhawk never made the front pages, but it won a different war, the quiet battle between what breaks and what endures. Its steel bones and human hands left behind a truth louder than victory. Strength isn't power, it's persistence. Each surviving machine is a memory of those who built, maintained, and believed in it. When its engine starts again in a museum decades later, that hum is more than sound. It's evidence that good engineering never dies. Respect the process.
Warhawk inbound.